Welcome everyone to another Observability Clinic, June 2022, and back in the office with Patrick. Hi Patrick.
Hey, Andy, how's it going?
Good. We had a great summer party last week.
Yes, we had. So that's why I'm lucky.
Yeah.
I can have this session today with you.
Yeah. Hey, today's topic is a practitioner guide to serverless observability, end-to-end serverless visibility with Dynatrace. Today's, as you said, it's June 2022. There's constantly things changing. And there has been a lot of changes over the last couple of months. And this is why I wanted to invite you to actually give people an overview of what's the current state of observability on serverless and also where the direction is heading. Right?
Exactly.
If people have questions later on, there's a way always to find you, right? Patrick Thurner, you're one of the product managers here that have been driving this for many years now. And so folks, if you're watching this, whether on YouTube or Dynatrace University, I'm pretty sure you'll find a way how to get a hold of Patrick. One way is obviously through the Dynatrace University or the community.
Right, exactly. What always goes on the community, watching the insights and feedback we get there.
Mm-hmm. Let's jump in.
Absolutely.
Yeah. What do you have for us today?
So, today we're looking into the landscape of serverless. So serverless is a really broad topic and sometimes a little bit misunderstood in terms of what is meant with serverless. So we're looking into serverless topic itself and its use cases and also the involved challenges about that. So then we're looking at what we actually delivered in the recent time from a product point of view and how we can leverage that for serverless. As well, do we give a glimpse into the roadmap, what's around the corner. Cool. So let's jump into first what's kind of the major cloud scenarios. You know, when we talk about serverless, it's super important. So the first major scenario we typically see is a kind of a hybrid cloud app scenario. So that's where you really have your new greenfield kind of application running in the cloud, but that still connects to your existing on-prem or hybrid private cloud, whatever it is. So that's where a lot of customers are in this situation because, you know, lift and shift is hard. They may just keep the existing stuff in their data centers and so on and so forth, but new teams start developing mobile apps, cloud native workloads. And that's what they use to connect with the existing data centers. The second scenario where also serverless is heavily used is the hybrid cloud scale scenario. That's where you have kind of, again, existing application, whether it's even a front end running with traditional stacks, app services, and things like that. But you get also this need of scaling out for Black Friday scenario, something like that. You want to use the latest and greatest technologies in the cloud. So like data mining, you're pushing all your data into the cloud, you use Spark managed kind of scenarios to process these things. Again, it's hybrid, but it's kind of the opposite side of the house. And the very last one, which is fully kind of cloud native, where you really start completely greenfield in the cloud. It's not only startups doing that, we as well as Dynatrace, you know, we have a cloud native approach. We have everything in the cloud. For sure, we have also on-prem things where we do testing and we have mainframe support. So that's a little bit hard in the cloud. But if you think about Dynatrace, the product that's fully cloud native app developed. And you have all these kind of mixed scenarios. And that's also important when we look at serverless, that it not only exists in its own kind of isolated world of cloud, it really typically interacts with all the different kinds of bits and pieces. Could be mainframe, could be kind of a traditional stack. And we kind of, in Dynatrace, you know, we cover it all. That's the cool part.
Yeah. I really like that overview, by the way, because typically when I talk with organizations, we talk a lot about cloud migration strategies, where you talk about your lift and shift, you retain, you retire, your re-platform, you re-architect, and this is a great way of actually explaining what type of options do you have as you modernize your applications. And exactly. I think it's a nice gradual approach. Yeah.
And I like it very much because sometimes when people think about serverless, they think, oh, that's nothing for me because, you know, we're a traditional company. We use cloud, but you typically blend it out. But I think that's important to just set the stage.
Perfect.
Cool. So that's another slide I used in a previous presentation. It still works, you know, it's the famous iceberg. Again, I mentioned when we talk about serverless, often the industry just looks at the function as a service offerings from cloud vendors. There's Azure Functions, AWS Lambda, Google Cloud Functions. But from our point of view, that's way more. Also how cloud vendors look into that. So if you look at the whole application stack within serverless or even more broader, like cloud native app development, we have basically serverless anything. You have a serverless backend, like databases, fully elastic kind of offerings, whether it's DynamoDB, whether it's SQL databases. So all this is fully managed kind of by cloud providers. You have API gateways, all these things which are fully managed. Then for sure, you have Kubernetes, whether it's native Kubernetes or a managed one, or use any of these kind of other frameworks in the cloud available. So there's a very heterogeneous way of how cloud apps are implemented. And with all this kind of big picture, you get all these new challenges to it. Like, hey, you have so many data sources to capture the data from. If you think just about serverless, pretty much every service has a different way to expose its metrics, telemetry, whether they have extensions, whether you need to capture the data from the cloud vendors' APIs. So it's very, very scattered around. Again, also with this kind of new services, new architectures in developing new applications have arisen. So microservices is in everybody's mouse and kind of normal today, but is new patterns evolve, you know, with challenging the cloud services, voters kind of having trends and fault handling in their applications. So there's new things for us also as a product to consider in terms of applying domain knowledge to Davis. That we are also tackling as well. And with just the out-of-the-box experience from Davis and root cause analysis, that already helps because we build really kind of knowledge in root cause analysis that also works already today for this kind of scenarios.
That's cool. So that means there's probably certain new metrics or some type of information we can pull out from these frameworks, whether it's the vendors itself or whatever framework you use. And based on this, we know if something actually goes wrong or right.
Exactly.
And that's awesome.
Just think about quota metrics of a service. You're reaching some quota, and we can anomaly detection on that. Or you get some advanced that kind of a platform shift has moved your workload around. We can put it as an event into Dynatrace and kind of alert you if something happens.
I mean, maybe you'll cover this later, but the quota is an interesting one. That means when you are calling an API too often, or when you are called too often and therefore you're outreaching your quota, I assume then a certain event is raised, a certain log message, a certain HTTP status code gets returned, and we are detecting this now automatically.
Not automatically as of now, but we just still figure out, hey, there's an issue, but you have all the telemetry in Dynatrace to drill into and look into that.
That's awesome.
We're working on that, we get it as a fully kind of influenced root cause, kind of that we're pinpointing, hey, this was kind of a, you know, a throttling event or something like that. Right now, you would still need to dig into. And that already shows how scattered the landscape is, because pretty much every service, as I mentioned, has a different way to tell kind of such events. Like some APIs returned as an HTTP header, others raise an event in the cloud log or things like that. Others have just metrics. That's the tricky part. If you have a kind of a multi-cloud application or a multi-service application, to really put these things in context and not need to handle all this kind of telemetry signals very uniquely. So that's the goal we want to achieve, making it really easy for our customers. So that already leads me into kind of what we have and what we provided basically. So let's first jump into our kind of support matrix when we think about serverless functions. And today we're just looking at serverless functions to be precise, and didn't mention that in the beginning. So there's other topics we're focusing on other services than like managed containers. Today it's just about functions as service. So when we look at our support matrix, it's already huge. So we support all the different kinds of cloud functions. So today, as I mentioned, cloud functions from Google, Lambda, Azure functions from all different angles with distributed tracing, infrastructure level insights, log monitoring, and so on and so forth. So what this matrix doesn't give you, and that leads me back, is kind of how it works basically. how it works for the different kind of offerings. So right now we have, for example, Lambda extensions for AWS Lambda for the three major languages like Java, Node.js, and Python. We just enable this extension and automatically starts monitoring and tracing your functions, which gives you the full insights in Dynatrace. Like you would have a traditional workload, like on Kubernetes. You have the topology, you have AI-enabled services, and things like that. So all this standard Dynatrace convenience you get out of the box. But when it comes to other runtimes languages, we already propose to use OpenTelemetry. The reason is not simply because we don't have an agent for that. Many of these platforms have restrictions in terms of what you can do at runtime because it's a fully sandboxed environment. You just deploy a container package, and that kind of restricts us from the approach how to inject agents. Also for Lambda, we came up with a complete new architecture on the agent side of the house to really fulfill the needs and goals of service monitoring, like reducing the startup overhead and things like that. So with that, kind of the approach was a little bit scattered, and not everyone is already familiar with OpenTelemetry. You had recently an Observability Clinic on that one. So that's kind of still a challenge. So it's an emerging kind of standard, but not everyone is mature enough to use it out of the box. So that kind of, we saw it's hard for customers, and also the experience in Dynatrace is not at the same level as with whether we would use the fully one agent kind of enabled services. So that's what we tackled basically, and really enhanced OpenTelemetry and made it really easier to use, enabled a lot of capabilities in there with our own Dynatrace exporter that basically speaks kind of the language that the one agent speaks and really unlocks all the capabilities in our analytics engine. So when we look at Dynatrace distributed tracing, that's what we had before with OpenTelemetry. We had the end-to-end view. You can mix and match with one agent, non-one agent. So that's the real neat thing. So what we did here is really elevating, because now with the new exporter, we can do service detection things out of the box. So you don't get just a simple trace. You can drill down and look into, you get the really kind of service kind of view on.
So the music also gets some metadata and
service-based things. So that's the things we're working. So I'll come to that a little bit later. So from an instrumentation point of view, with Lambda, for example, with the automatic instrumentation with the agent, still you use typically a combination with OpenTelemetry and the OpenTelemetry SDK to enrich the instrumentation. Because there's so many frameworks, and also AWS provides their own distribution of OpenTelemetry, which comes with pre-instrumented AWS SDKs. So that's kind of the approach for Lambda, and we basically still work on that. But we came up with our own instrumentation libraries specific for FAS to make it even easier. You know, OpenTelemetry is still a lot of boilerplate to write. You might not be familiar with trace context propagation, so really putting things along your trace. And that's something we enhanced with our own enhanced libraries.
Cool. That means you automatically take care of this, that the trace context is passed on on the message you're sending out.
Exactly.
That's cool.
So that's just enhancement over there. So I mentioned the service detection already. So today, with just ingesting spans, you have seen the end-to-end trace. You get the service flow if there's something in between. But without service detection, you don't see all the hops of your function invocations in there. So that's also something which you just get now out of the box and getting all the kind of analytics capabilities involved with it. So also the automatic service analysis with service level baselining, like response time anomalies and things like that. So that comes out of the box without requiring our customers to write customer alerts or doing things like that.
Well, that's one of the reasons why customers buy Dynatrace, because we do a lot of automatic detection, automatic baselining, automatic alerting.
Exactly. So that's a real kind of, you can still do it today, you know, with this dynamic alerting and things like that, but it's way more effort to also configure in Dynatrace to get this kind of things. With that, I mentioned services are a critical piece to detect and putting things in context, like the horizontal topology in the service flow. So that's where topology helps, and also helps Davis basically to really detect the root cause of failing services, for example. Last but not least, and that's one of my favorite kind of features, I'll show that more. We heavily improved also in the visualization to analyze all these metrics. It's not about traces only. So, you know, we get mixed insights into logs and cloud service metrics. And now we came up with a new visualization that really helps us to analyze these things in context on a single screen, fully enabled.
Yeah, I think this is the new unified analysis screens that we have in Dynatrace. I also did a clinic on that recently with Stefan Radu, who also showed how extensions 2.0 can leverage the same thing. And we as Dynatrace just moving to this new way of visualizing. It gives you a lot of flexibility, and it's great that we are seeing more and more screens in Dynatrace also adopting it.
Exactly. It's a really cool feature to really drill into specific issues, whether you're proactively looking into kind of the service level behavior and see, hey, there's an anomaly, or not even anomaly, there's kind of a point of interest I want to dig into because there's something I can improve, or you get the problem and you may not have the real kind of root cause. Maybe it's in a code level detail anywhere, but you can drill down from the problem to the service, have everything in an overview. From there, you get all the metrics, logs, you can get into the logs or into a specific trace and dig into that one. Cool. And last but not least, also, you know, how all these things are kind of licensed. The packaging is something which is important with open telemetry and trace ingest. It was basically different license. We counted spans, which is always hard to estimate. You know, if you're a large enterprise and you have thousands of functions, some functions are producing 1 spans, others 10 spans, 50 spans, who knows? And that's kind of, you know, hard to deal with. And now we unified also this approach with this exporter to count by service invocations to get these metrics out of kind of your cloud vendors APIs, and that's where you exactly know what really the observability costs are for your environment. So now it's already demo time. So I talked a lot about, you know, it's a kind of an SD overview of metrics.
And now we see if you can not only do PowerPoint programming. Right. Let's see it in action.
Let's see it in action. So let's switch over to the product. So that's why you already see, that's our service overview. And we're looking into that one. You see all these kind of services, and these Lambda services are all not monitored, for example, with our Lambda extensions. These are already monitored with our new Dynatrace export. And I show it afterwards how this really looks. But let's start first how it looks in the product. So you have all these kind of services fully detected. There was no need to really manually configure something to detect something out of spans. As soon as if you're using our libraries and the Dynatrace exporter and you published it, these are popping up. So if you're looking into some one of that, that's kind of a function. You see all these tags combined. So many of these informations in here of the properties and all the tags, these already come from the CloudWatch integration. So
that's great.
Previously, you saw them a little bit scattered around the product, and now you have it on the same screen where you have your service detected. In that case, luckily, we don't have any problems, but kind of you have all kind of features available, like you would have on the typical Dynatrace service screen, like MDA analysis. You can drill them in all this kind of error analysis kind of views and so on and so forth. But here on the top, you have the baseline kind of service metrics. So the health metrics like response time, throughput, error rate, what we detect out of the box. And then we already drill into the kind of metrics we get from CloudWatch. So that's the cool thing. As I said, everything on the plan, we have some kind of aggregated or kind of calculated metrics to really measure the availability of the metrics. That's rather cool because sometimes with the agent injected, the runtime may be just crashes or something like that.
Yeah.
And we don't get this crash without, we just don't get any trace level data at that point. So in that sense, using the cloud vendor metrics, we always have an external view of our functions if it's still available. So you would see, for example, if you would have way more invocations than actually throughput on the function level. Yeah. So that's how we calculate, for example, the availability of your function.
That's awesome. So that's the method, because I work a lot with site reliability engineers these days, and a reliability metric like this is perfect. So just so to get it right, we're looking at how many requests are coming in and how many are actually executed, and based on that we can actually say how many were really processed from the overall.
Exactly, and that would give you a good availability.
Yeah,
because if you're in a process and the process is killed,
of course,
it's a way. So in best case you get an alert by Dynatrace, but it gives you a little bit of more insights.
Awesome.
And also that screen basically works if you just have either tracing or CloudWatch metrics enabled. So that's really you just get more or less insights on that screen.
That's great. Wow.
And that's where you have all these insights into cold start metrics and whatever is available for each services. You see how the upstream and downstream services behavior. Like we previously, on the service level screen, we had these calling services and the other outbound services. Now we show you also already these kind of services with some insights how they behave in here, and you can immediately drill into. You see all these insights.
That is really cool, because as a developer of a service, right, you obviously want to know who calls you and what's the performance from them, but also the services that you are depending on. If you have a certain performance budget, then I immediately know if the services like downstream, how they're behaving, who I'm actually calling. That's also nice. Yeah, I see it here. That's really beautiful.
Yeah, I like that, and that's exactly what we mentioned before. If this other kind of service might be throttled, something like that, you would see that immediately here from kind of a metrics point of view. And in future, we're targeting to enrich that really with root cause analysis, so that we exactly know, hey, this kind of service is not just slower or unresponsive, but it has kind of a throttling event right now. So it would resolve its issue after a while on its own. So,
and then coming back to your multiple hybrid cloud models that you had in the beginning, right, where you explained this actually, for the people that don't know it, I mean, we see here upstream another Lambda function and downstream another Lambda function, but also request to armored host. That means it actually goes also if you're calling other services that might live in Kubernetes cluster or on-premise. Right?
On-premise, it could be any third party. If it's just an API you're calling, like the cloud vendor's API, which is not monitored, you would see that.
Yeah.
And as I mentioned before, the cool thing with one agent, whether it's the new agent for serverless, the full stack one agent or open telemetry, you can really mix and match. It's always the end-to-end view here. And for sure, we have all the beauty of other telemetry insights like events, and also log monitoring is something which is coming in here as well. So just that you see also that how this looks like. I mentioned already the service flow, which is super critical, which we had before for Lambda monitoring. Now you get the full service flow from one single function to another. Haven't chosen the best service, and typically we have a very extended one, which really shows connected to one agent and other services, but it's really reducing the blind spots in the product, which you would otherwise need to drill into kind of the distributed traces and following in here. So let's get back. So also here, just you see also the enhancements on the distributed tracing level. Let's see some of the invocations, and you get in here also here. Now you have the full call hierarchy of the services on the top left. So that's where you typically see, hey, that would be just a purely open telemetry monitored services, where you see all the spans, which is great. But a service level view on the things is always a different way with all the aggregated information. You have all the information like you would have with any other service, which is really cool, including all the spans. In that case, we don't have any additional spans, but you would see that as well.
If you do me a favor, scroll up on the left. Because this is really where you can actually get all the way up, right? Because you are actually looking here
at the very specific,
like the invocation lambda sample function that really then goes from Java all the way into different. This is really cool.
Yeah, it's really the end-to-end view across everything.
Yeah, including I saw some database calls in there as well. If you scroll up a little bit, I think that's what you were looking for. I guess you can you do me a favor. I don't want to direct you too much, but if you click the very first entry on the very top, the root node, if you click it, right, we should see the full end-to-end path. Yeah, that's pretty cool. And also the summary, which just shows you actually which request comes in from the very top. And here we go. Yeah,
you mean the waterfall. So that's the visual one. So
exactly.
It's sometimes helpful, but it's catchy that you get really the timings across everything from spans, mixed, matched. And as I mentioned, for example, Cloud vendors already pre-instrument the libraries like AWS with this to us. So instead of instrumenting every kind of DynamoDB call, as an example, we just enable open telemetry. We automatically capture this instrumentation. So it's really a complete different level of using open telemetry in that sense. So something I also wanted to show was, for example, if you're on, let's choose another cloud vendor. So I would just
because we often look at AWS anyway.
Right, so it was already pretty good covered. So if you look at Azure Functions, for example, so that's the infrastructure level view. If you turn on the cloud integration for Azure Monitor, we automatically capture all the service level metrics, what we get from Azure Monitor, together with metadata and things like the tags. So you can enable, so that's kind of a non-instrumented way of things. Oh, seems in our demo environment right now, we have just turned off pretty much of the tracing for these functions. Okay, it's our internal library. Let me see if I have something else. If I have another subscription. Maybe let's stick to AWS. From here, if you jump into your Lambda functions, okay, also here, here we have some instrumented functions. So that's where you can drill down into the service.
Yeah, so that means, just to understand this, when we're just pulling data in through the CloudWatch metrics, then obviously we see all the functions, and if there's additionally instrumented with OpenTelemetry, then you get all of these details.
Exactly. So you really drill down into that screen, and basically that's where you land in. So it's really interconnected and really pulling all these metrics in here. So that's that one, and maybe just last but not least, also to show it's real for everything. We have the services, and we filter just I'll use that view in here for Google Functions, for example. Also in Google Functions, we basically have the same. You see the full service detection. It's always the same, The approach is pretty much the same. And yeah, it's real, it's there. I love it. It just gives you all the kind of out-of-the-box experience also for serverless environments.
And from my understanding, a function is always equal to one service instance.
Yes, that's right. So in Azure, basically the approach is a little bit different because in one function service itself, you can have multiple function services.
Okay.
But still we want to dedicate one service for each kind of function because that kind of aligns like you would have a Google Cloud function or
that makes sense. So to unify it,
And also we're working, a lot on constant improvements for service detection. So in future we will be really more flexible and kind of merging these things and separating these things, especially also for Lambda. But now we have still this process group monitor, which is not applicable to serverless because there are no processes basic, or you still have processes, but in that sense you have not the flexibility because you lack a lot of the insights of what's going on with processes. So yeah, that's that, and let's maybe jump over to kind of more insights on the instrumentation piece. I mentioned already that kind of the instrumentation for these services with this new approach using the Dynatrace exporter for OpenTelemetry is still manually. Let's just first have a glimpse on the standard OpenTelemetry exporter, what the kind of effort is to really implement. You need to instrument your code. This might differ depending on the language. You might have pre-instrumented libraries or not. Are you manually instrumented? That's kind of a nasty piece to tackle. What is there? You configure a tracer, and then you have to mandatory or not mandatory use an OpenTelemetry collector as a kind of middleware that really acts as an endpoint to gather all this data and forward it potential Dynatrace. Or you want to just route traffic from multiple services to one endpoint, and from there you go to Dynatrace because you don't want to have all the single connections from your services to Dynatrace. Similar to an ActiveGate component. Managing and running this kind of OpenTelemetry collector could be really a masterpiece for many operators. We know that from our own with ActiveGates, which has a lot of smartness in it to load balance and do network traffic. So it's something you have to take care of on your own with collector. So that's something you have. Then you still need the configuration Dynatrace to work with the spans, what you want to detect on spans and things like that. So there's a lot of effort involved to get it done. And with our new Dynatrace exporter, you get rid of most of this telemetry specific stuff. You could still use the same instrumentation as you had before, but you don't need an collector. We still have you can use your ActiveGate infrastructure, for example, or directly the cluster endpoint. So it's using the same kind of components as you would have with any other agent. And the only thing what happens still is you just tell OpenTelemetry, use our Dynatrace exporter. We made it with some helper functions easy in our libraries, and just go for it. And then I mentioned that by adding kind of advanced libraries for instrumentation, specifically for FAST, where you just tell, instead of saying, hey, read this kind of tag from the request, put it on the parent kind of trace context and pass it over to somewhere, which is kind of made helper functions, as you will, where you just say you have an entry point of span, pass in kind of the incoming event object or request, and it automatically propagates the same kind of things. So we already reduced the effort of code instrumentation.
Yeah, because you don't need to take care of this yourself anymore, right? I guess, yeah, you're just hooking into certain functions of that framework.
Because with OpenTelemetry on its own, you have to knowledge about distributed tracing, trace context, and things like that. With FAST and cloud vendors, then you have to have your knowledge about how these things are coming in. There are multiple ways to pass in request attributes. So this adds another complexity, and we try to reduce this effort. So, and there's still this point of, hey, I don't want or I cannot touch my kind of code to add instrumentation. And that's where it's really kind of to whom do you talk? Because if you talk to kind of developers, they're not scared at all with that. Touching the code is not a big deal. But even there, you might have the policy, we don't want to touch all the time our code, maintain. Monitoring code can also be kind of a lot of effort. And that's where I showed it in a second, have put together basically a proof of concept, how you can just utilize existing programming patterns like aspect-oriented programming or kind of other patterns to really add instrumentation to your functions without the need of knowing OpenTelemetry, distributed tracing, something like that. Just abstracted kind of logic away. You just apply a kind of library, a custom written library to your code, and that's done doing all the magic. You benefit all from this kind of monitoring as code or kind of approach. You deploy monitoring along with your kind of deployment package. You have it maybe controlled by your CI/CD pipeline to change insight level. You maybe want to have the full insights of even tracing in pre-production, but as soon as you roll out, you reduce kind of the insights in terms of tracing, or you don't need every kind of framework instrument. So that's all there.
cool. And then what you built here, this proof of concept, and with the custom attributes that are on top of these functions, is this done then during compile time, or it's a runtime thing that you do?
So in my case, it's done at runtime. So I'm using, so that's the example is for Azure Functions and .NET. So there's favorite frameworks like Dynamic Castle Proxy and using a dependency injection tool like Artifact, for example, it really enables that. And that, for example, is wrapping basically your functions by applying rules to detect which kind of function it needs to override. And it, basically every virtual function then gets automatically wrapped. And that's why you typically have a single point where you just say, hey, start my span, end my span with our new libraries, and it's really simple. Cool. Let me jump over in here. And the cool thing in here is, and in the former days, before APM, many customers used, for example, aspect-oriented programming to add logging to their kind of code without touching the code, which is really neat. And it doesn't need to be aspect-oriented program, could be any kind of other approach which works best for the company and customers, but it should just show you the direction. No fear from kind of touching your code. In that case, you would see, for example, that's a classic Azure Functions, and you see there's no, and it's just kind of just logging out there. You have an HTTP client calling the other function, that's kind of a ping pong function. That's all on GitHub. So one just needs to check out the project and run it. There's no monitoring code at all in here. So the only thing what you would apply is a kind of a monitoring policy, add a specific library to it. And I use this kind of, see here, so that's kind of, slowly.
I think it might be easier if you look at your screen when you move it down, because you're looking at the
timely delay.
Exactly.
So, so that's one of the kind of libraries for the proof of concept I created. It's really a NuGet package. You drop it, and it completely adds all the necessary code dependencies, and a startup function which starts instrumenting the kind of or wrapping the function with Dynamic Castle. And the only necessity to get this done basically is making sure that it's not a static class, because in Azure Functions typically start with a project which is a static class. You just remove the static in here, so you can really, the Dynamic Proxy can inherit this class and make the functions inheritable with virtual. That's all. And you get the full end-to-end tracing, no fiddling around with OpenTelemetry, no fiddling around with distributed tracing. That's really nice. And that's what you can really apply at large scale. So we have customers, they just want to try out things, even in production, and going to developers for things to test out the distributed tracing. That's kind of hard to convince them. And with that, you say, hey, you can just drop this kind of library, change your interface, and then we can test at least a couple of functions and takes a couple of minutes. So yeah, so again,
you should pitch this to Microsoft, so maybe they build something that is by default into the product.
Yeah. So also, and for Microsoft, it works for every language, for every runtime, works for AWS and Google. So I think they are aware, but same as we don't support kind of such libraries as Dynatrace for that, it's hard to support, because there's thousands of frameworks to use that, thousands of approaches. Every company wants it kind of differently implemented. That's where you can just give you a starting point and to introduce this concept for distributed tracing, what was used before with logging. So I just wanted to make the proof that don't be afraid of touching a code. It can be really simply as dropping a kind of a library. Going back to PowerPoint, a lot of slides. We're already part of looking into what's next. So that was for sure not everything. So I mentioned the new service unification of screens, where we put all the signals onto a single screen. So that's not available as of today, but we're releasing that in August timeframe.
So August 2022 for people that are watching.
Yeah, August 22. So that's what really my highlight, because it really unlocks so much use cases in Dynatrace. And we know sometimes UX is a little bit hard, and that really unblocks a lot of things. And the other one is really further expanding the supported frameworks and languages. Right now, we have most important languages covered. We've extended to AWS Lambda.net, for example, but there's other languages. We have support for Google functions written in Node.js, and I think Golang has been already released, which is also very interesting. We see it very much used in there. And as I said, Azure Functions, we released .NET for consumption plan, we released Node.js, so the major languages. Python is following right now, so we're constantly developing these languages.
I see a lot of Python out there.
So Python is one of the most used frameworks in serverless functions, for sure, mostly used in AWS Lambda, for example. In .NET, naturally, many people are .NET developers, sure. Yeah, so right now also our instrumentation lab is mostly focused on HTTP incoming traffic. You can tackle all the others with custom instrumentation, but we also want to expand it into the more advanced scenarios like queue monitoring, message or queue tracing, message tracing. You really connect the traces for these kind of scenarios and middlewares, as well as databases. So an automatic service detection for DynamoDB, for example, for Lambda is coming. So which gives you all these kind of cool insights and the automatic insights, for, especially into databases. And also a big topic for this application monitoring, application log monitoring, where we really heavily invest to capture all the logs directly from the layer where we're sitting in, whether it's from the frameworks, whether it's from the runtime itself, without kind of using routes like CloudWatch, Azure Monitor, Log4, others, which will make operations much easier for our customers and really get a lot of these insights which are still stuck in application logs. And with that, there's just some links into our kind of documentation how this works. Also for this tutorial, which is public on GitHub, we might shift it onto our Dynatrace repository. And happy to answer any questions.
Yeah, pretty cool. So Patrick, what I take away from this is you taught me a lot about the different kind of cloud native models, which are really like models, the way you're moving into cloud native applications. I think what was also really interesting is your iceberg visualization with serverless is just really the surface, but there's a lot of other things that happen behind the scenes. Also, what I think is an interesting way of putting it is basically everything you consume in the cloud, every SaaS service is kind of like serverless because it's a database or something else. And I really like that you are educating people and making it easier for people to go into OpenTelemetry, even if they don't have all the experience. So with our libraries, we really make the entry point barrier much easier.
Yeah, that's one of the key things, because in some cases, it's the only way to get observability and like tracing into these functions. Not every cloud vendor is at this point having everything pre-instrumented. They're getting to this point, and meanwhile, we're just making it easier to get started with it.
Last thing, if I am an existing Dynatrace customer, or if I'm doing, let's say, a trial, I assume I just go to the hub and then there's a serverless tile and I can say, Dynatrace, I want to do serverless instrumentation. And then I also get all of these links.
Exactly. Just look for serverless, Azure Functions, AWS Lambda. You have all these links to enable this kind of telemetry signals. So you get to the right tutorials in there and then you're done. So cool. It's as easy as that.
Cool. Hey, Patrick, with this, I say thank you. And we will have you back because there's things happening.
Yeah, there are more things happening. As I said, serverless is more than just fast. So we're working heavily also on expanding our serverless managed containers. So we already support them very broadly today. But there's so much pace in the cloud vendor space to releasing new services. Many new Kubernetes-based services are coming up. So we're also looking very much into these kind of scenarios to keep up with the pace and make it really fully fledged at all edges.
Yeah. And final reminder, folks, if you want to talk with Patrick directly, you have his name. I'm pretty sure you'll find a way how to get a hold of him, especially on community.dynatrace.com. And yeah, that's it. Thank you.
Thanks for having me.
Yeah, I think we go for lunch now because it's not here.
Let's go for it.
Yeah. Okay. Bye.
Thanks. Bye-bye.